Alright, welcome back everyone to another video, and in this one, something I've wanted to take a look at for a while is the difference between the slowest uh, storage I have and the fastest storage I have, and how it affects compiling, say, the Linux kernel, where most of the workload is CPU bound, but storage also plays an important role. So we have my setup here, where on this end of the screen I have the fastest storage I have, which is around 3 gigabytes per second. It's an NVMe SSD, WD's 7 SM750 to be specific. And on this end I have a very fast NAS drive. Now it's fast from a NAS drive standpoint. It's on a full gigabit Ethernet LAN, and it's using the NFS protocol. So it's faster from that point, but not really as fast as it transfers at only 100 megabytes per second, since it's over gigabit LAN, and also the latency is very high. So that is what we are going to do. We are going to time how much time it takes to pull the kernel from Git, and then how much time it takes to build it. So let's get on with it. Again, I'm running Fedora. My machine is Intel Xeon something. It's a 4 core hyper-threaded, so 8 logical cores at around 4.2 to 3.7 gigahertz, depending upon how the day has been. And yeah, so let's get started. So let's go get full, and but I'll do depth equal to 1, because we just want a small benchmark. We don't want to pull the entire gig or 2 of repo that this is. So we'll time this, and again this is on my actual machine. um, let's see what the issue is. Should be git clone. How did I miss that? Alright, let's nuke that, and third time's the charm. So we are timing it, and we'll see how much of the CPU time it takes, and then we'll compare it while doing it again on the network attached storage. So on the other screen, while this is all being pulled, um, we'll run df edge, so you can see that NFS data is actually the network file storage from my LAN server, and that's attached again, as I said, over a gigabit LAN network. So we will wait till this is done. It should not take that much time, and once it's done we can get back and see how our times were. Alright, so on our SSD we took it took around 2 minutes and 16 seconds, which sounds about right. Now let's see and do the exact same thing on our NAS drive. So paste it and enter. Again, of course, the Linux already exists, and this time I'm actually thinking that is something useful, so we'll just pull it here, and let's see how long that takes. Which seems to be faster apparently. Okay, so maybe things are cached somewhere, and it's just pulling in faster. So just to try it out, I'm going to run the same command on the other side, but first. Alright, so the actual checkout files, this stage can take much longer than this particular stage here. So let's see, the network as is working hard. Yeah, this could take a while, and this is exactly where things start to fail. Not fail, but like slow down because this requires very low latency. Whereas I can run this exact same command on the SSD right now since it's not pulling anything, should be fine, or we'll wait for the sake of sanity of the test. But this could take a while. I'm saying at least 10 minutes, maybe more. It's only at 1%. So, yeah, I'll wait and I'll get back once it's done. Alright, so looks like it took 100 minutes to just, you know, check out the files, and this little step, it it's the it's the thing where it actually converts the whole thing, get downloads into actual usable files, and extracts them. So that's where we truly are with this. Although the actual download step was much faster for this one since things were already cached somewhere. Um, and here we had it at 1 Mbps, where there it was at 7.72. And I don't have a local caching server, so it was actually cached by my ISP or somewhere else in the system. But at least it was there, and like the checking out time just took um, a whole lot longer, whereas here it just took 2 minutes, which is fine. So cd linux, let's start and make. We'll just do a simple def config build with the regular stuff, x86 def config, and hopefully we'll get some decent times here. So time make def config, and this is mostly a single core step, takes around 2.2 seconds. Here cd linux 2 test, and do a make, do a time, make dev config, and it should take a while. Game comes out at 1 minute and 4 seconds, which is interesting. So here we'll start the build process. So time make all J16. Although this system has 8 logical cores, I'll just go with J16 just to hammer them all, and make sure the hard drive is kept busy. So we'll just wait for a few seconds, actually a few minutes, and this should be done in no time. Alright, so that came out to around 5 minutes and 36 seconds, which is not bad at all. Um, yeah, let's try it out on the other one. And let's go. So this I am thinking will take a lot of time. Um, so we will get back. I mean, the compilation has started and my CPU is barely hitting 50%. Um, of course, on the one where the NVMe was involved, it was hitting 100% the whole time. I'm seeing the CPU set around on 25 ish per core. Um, yeah, and this is the kind of thing you'd expect where the storage is too slow. The CPU utilization won't be there at all. Alright, so something weird happened. It actually ended up building the image in 9 minutes 19 seconds, so it's not that bad from 5 minutes. But also, I see this error called CRC, um, and that's usually to do with IO errors, although I cannot find anything else on the log. It's not as efficient, and you are probably better off building it on your own machine. So I'm not trying to prove anything here. It was just a experiment I've been wanting to try out for a while, and finally got to it and thought I'd share. The entire recording took about 8 hours, I think, and that's because not because of the system itself, not because of how slow it is. I just forgot about it. I put it up, I went to bed, and I forgot I ever did this. Came back 8 hours later, and there we are. So thank you so much for watching. I'll keep updated. I'll keep you guys updated with small videos like this over the time. I do have few major projects in the works, but they are just taking a lot longer than I anticipated. So thank you so much for watching, and I'll see you all in the next one.